All right, our next speaker is Akanksha Mahajan. Akanksha is a software engineer in Apple. She works on backup and restore for FoundationDB. She's passionate about distributed databases and storage systems. Prior to Apple, she was part of the storage team in LinkedIn. And before that, she spent 5 years at Meta as an engineer at the RocksDB team. And she's going to be talking about encryption for backup. So warm round of applause for Akanksha.
Hello, everyone. Thank you for joining. My name is Akanksha Mahajan, and I'm a software engineer in FoundationDB team at Apple. And I've been working on backup subsystem, and today I'm going to talk about encryption for FoundationDB backups. Here's an agenda for today. First, we'll go through the motivation that why we build this encryption and encryption feature, and why we'll go over the overview of how backup works today, and also about the why the existing security is there's a real gap between the current implementation for encryption. Then we'll talk about the design. We'll cover cipher, keys, and the encryption block size. And lastly, we'll cover the usage, how to run an encrypted backup, how to debug, monitor, and how to deploy the keys. So first, we'll go over the high-level overview of how currently the backup works. So on your left, you will see an FDB cluster. This is where your data lives. Now, if you want to run a backup, you have to start a FDB backup start command. Now, FDB cluster itself, it doesn't do any backup work. It's done by a separate set of processes called backup agents. Backup agents have their own set of machines, and their work is to read the data out from the FDB cluster to the backup container. As you can see the backup container on the right side of the diagram. Uh, Now the backup container is something that a user provides. It's a destination where you want your backup data to land. And if you see in the backup container, the layout is that there are 4 folders. First is the snapshot. It's basically a manifest file which is in JSON format, and it contains the list of the all range files which belong to that snapshot. And then we have KV ranges, which contains the actual key value data. So basically each range file, it contains a portion of your key space, and your entire data, it's divided into multiple range files. And then we have logs folder, which captures all the changes that have been made during the backup window. And then we have properties folder where there's multiple metadata files. And now if you want to do the restore, the process is similar, just in the reverse of what we have talked about. Backup agents, they read the data out from the container into the FDB cluster. Now, the one thing that I want you to take away from this slide is that the backup data, it leaves your infrastructure, as you can see on the left side. And once the backup data, it lands on an external storage, there's nothing in the cluster, in FTP cluster or your infrastructure, that is protecting that backup. Which brings us to the problem that your backup data, which is in the which is in the container, it's in plain text. So if you grab one of those files and open it in a random text editor, you would be able to see the actual key values as it is in your database. Now, if we go further, you might be thinking that it's not like we don't have any encryption at all. We have TLS, we have server-side encryption, and that is true. But TLS is for data in motion. Technically, the seconds the backup data, it lands on S3 or Azure or any other container, TLS work is done. It is only for network layer protection. And server-side encryption, it does provide the encryption. So in a way, your backup data is not really in plain text. But the question to ask here is that who owns this key and the encryption? And answer to that is the cloud provider. So if something happens or something is compromised or credentials are leaked, then the attacker would be able to make get request calls and will be able to read your backup data. So which leaves us to a gap, which is that you, the data owner, doesn't own the key and the encryption. And this is what this feature covers about. So the idea is that that your files, backup files, are encrypted and you owe the key. And once it lands on an external storage, so even if something happens and attacker is able to access the file, that person won't be able to read the data because he doesn't have the key. Now let's move on to the design part. So the first question to ask is like, what should we encrypt and what shouldn't? And the answer is simple. Whichever files contain the key values, we will encrypt that. And that is snapshot files, range files, and log files. We are not encrypting anything in the properties folder because that's just metadata. And this is what current files which are present in properties. So we have added a new file, encryption metadata. It's a JSON file and it contains information that if the backup is encrypted and what's the encryption block size, which we'll discuss in the next few slides. It's created when a backup is submitted, and this is the first file that restore reads when the restore happens, so that it knows that the backup is encrypted and what's the block size. And for the cipher, we are using AES 256 GCM, which is widely used and well-established one. Most of the security systems use that. And the key is 32 bytes, which you save in a file on a disk. Now, how to pass this to FTP cluster to encrypt? You will be passing as an argument to the FTP backup start command that we saw in the first few slides. So you will not be passing the key bytes itself. It will be the bytes in the file, because we don't want anything on the command line, we don't want key bytes on the command line because it might end up in places where we don't want sensitive data to be, for example, shell history or PS output. And this is how the encrypted file looks. So we are not encrypting the whole file as a one giant block. Rather, we are dividing the file into multiple blocks. And that block size is configurable, which we call encryption block size. By default, it is 1 MB, but it is configurable and can be passed through FTP backup start command. And for IV derivation, so basically GCM AES 256, for the cipher, it needs two values for cipher. First is the key and second is the value. And the value here is IV, which is initialization vector. Now the rule is that for the same key, IV has to be different. And the reason is that if an attacker has two ciphertext with same key and same IV, he would be able to understand the encryption. So that's why in our case, for every block in every file, because we have same key, the IV has to be different. And how do we generate the IV? It's not random, it's deterministic. So what we do is that IV, because it's 16 bytes, first 12 bytes is the hash of the file name, and the last 4 bytes is the block index. This way it is deterministic, and the plus point is that we don't have to store any metadata about the IV anywhere. During restore, we can recompute this value IV during decryption using the file name and the block index. Lastly, we'll discuss about the usage, how to encrypt the backups. So here's a table of mainly backup commands which we generally use and how they interact with two flags, which is encryption key file and encryption block size. So for FTP backup start, if you want to encrypt the backup, you have to provide the key, which contains the key bytes, and encryption block size, as we have discussed, is optional. And during restore, you have to provide the key if the backup is encrypted, and the key has to be same. The key file name has to be the same. And we don't pass the encryption block size because it reads from the metadata. And for the modify command, if the URL is same, then you don't have to pass the key. Otherwise, for a new URL, you can pass, it's up to you. And for FDB backup describe command, it reads the data from the properties folder, so it doesn't need any information. Next is how to deploy the key value. The key file. Now the key file has to be at the same absolute path for all the hosts that need this key. And which are the hosts that need this key is, first is the backup agent, because we have discussed earlier that backup agents are the one who copy the data. So they are the one who encrypt and decrypt. And the second one is the FDB restore client process, because it reads that snapshot manifest file to do some verification. So these are the two categories that needs this key file. And other processes don't need the key. For visibility purposes, we have added this information in FDB CLI status JSON as well. As you can see that backup agent A is able to read the key file, but it's not able to read the old key. And for tags also, we have added the information which backup is encrypted or not, and what's the encryption key file used. And same information is added to the FTP backup describe command as well. And lastly, we'll discuss what happens if something goes wrong. And the good thing is that we have tried hard to make every failure mode as loud and as early as possible, so that we don't leave restore in any corrupted state. So if you are during restore, if you are passing a wrong key, the FDB restore client process will fail. Similarly, if you are restoring without a key and the backup is encrypted, the process will fail without going further. Same is with the modify command. If you're passing to a same URL, to the same container, if you're passing a different key, it will reject, because we don't want to mix the files encrypted with different keys. Yeah, and this feature we are hoping it will be production ready in next release in 7.3 and 7.4 as well. Yeah, that's all.
Thank you so much. Do you wrap the data key with a top level key and use the encrypted key in order to further encrypt the data, or
No,
it go straight?
No, we don't do that. Yeah,
Okay.
whatever key that you provide, the user provide, we use that.
How do you do key rotation?
We don't support that right now.
Okay.
Hey, I got a question. I I thought of a new question. I never asked you this. Um, so FTB runs on processes that are like one core, right? And sometimes we get interesting behavior with using up all the CPU. So does the cost of the encryption, does that do anything to any of these processes that users should be aware of and should plan for in terms of like provisioning and machine resources? What do we see there?
Yeah, so we are still testing, but definitely we see a bit increase in the CPU usage. But that's only for backup agents because they are using these files for encryption and decryption.
Do we have a recommendation in terms of like you should go from like n to n times 2 or 1.5?
I
Or
think
do
it
you have
was
any number like that?
around 7% something. Yeah, I'm not sure. I need to check the exact numbers. Yeah, yeah.
But we can provide guidance, I guess, right?
It's kind of orthogonal, not related to encryption, but like we've noticed, we did a restore. We had to do a restore to like one of the clusters, and it took an incredibly long time, right? Are there any knobs or like things we can do to like decrease this restore time?
Yeah, that we know that restore takes a lot of time. So that's why we are working on another version like V2 and all. Yeah.
Awesome.
So the for the restore case, so we are trying to improve the backup. So we are trying to have two improvements planned for both snapshots because every restore involves two stages. We have to restore the snapshots and also the mutation logs. So for snapshots, we are trying to use the concept of like bulk loading. So we'll try to download the SSD file where it contains the keys and ranges and directly add to the storage server so that it avoids all the transaction system going through to the commit proxies transaction logs. And for the mutation logs, we are trying to make as small as possible so that when you're given a key range, we can just download the mutation log for that particular key range and directly send it to the commit proxy. So we can parallelize the stuff because currently with backup V1, everything is stored in the same file. It's all mixed up. So when we're applying, we have to constantly check on whether that snapshot is applied and whether that mutation looks have to be applied. So there's a kind of a bottleneck. And it also has to go to the transaction system. So we're working on these problems. So in backup V3, yeah, I think it should significantly improve the speed compared to backup V1. So yeah, we're still working on it. Oh no, irrespective of the storage engine, it should work.
Thanks everyone for coming again. Thank you, Trevor. Thank you, Akanksha, for your insightful talks. Thanks to all the folks from OpenAI, XAI, Palantir. Great showing. Thanks, Evan, for showing up. I feel honored that you show up. So we can hang out here for another 15, 20 minutes. So if you guys want to talk to each other, ask questions, socialize, go ahead. And if you're interested in giving a talk at this forum, just email me and we'll go from there. So thanks again.